So up until this point, we've been talking about functions, just like we saw in calculus 1 and 2, just we've had more variables in them. So we're going to kind of take a different approach now, which is going to allow us to move further into what we need for this course, and we're going to introduce the notion of vectors. So basically, in most of your math classes, maybe all of them so far, you've dealt with numbers and functions. But often in the real world, things are measured by more than just a single number. So just a quick couple of examples. If I wanted to give you directions to a coffee shop, it doesn't do any good if I just tell you the coffee shop is 1 mile away. That's not going to help you get there. What you also need to know is 1 mile away and in which direction that 1 mile is, so you know which direction to walk to get to the coffee shop. Similarly, you can think of if you're talking about your velocity, saying I'm going 50 miles per hour is nice, but it doesn't tell you a lot. Are you going 50 miles per hour east? Or are you going 50 miles per hour west? And so on. So what we like are these objects called vectors that have a magnitude and a direction. So for velocity, you have a speed and the direction you're traveling. For, say, displacement, you'd have how far you're going to go, like a mile, and in which direction, say, east. So we usually denote the vectors either by a boldface letter like V or a V with an arrow over the top of it. And the magnitude of the vector, so that's the length. So like for velocity, that's the speed. For displacement, how far you're going. This is usually two little lines on each side of the vector. So like I said, there's a couple examples. I walked 1 mile north, or I drove east at 70 miles per hour. So each of those has a direction and a magnitude associated with it. So we generally represent our vectors by arrows, and these aren't tied to a particular location, so we can move them around. So if I say I go east at 50 miles per hour, it isn't tied to a particular location. East at 50 miles per hour is the same no matter where you're at. So for instance, I might have a vector here, v. So notice it's just an arrow pointing in a direction. But if I look at the vector here, v, I can put it in any of these spots. You can notice that each of these arrows is going in the same direction and has the same magnitude. So they're actually the same vector. So that's one thing to get used to, is you can pick a vector up and move it around as long as you don't change the length of it or the direction it's going. So one other thing we can do is we can scale the magnitude of a vector. So if you're going a certain velocity, so east at 50 miles per hour, I can double my speed so that I'm going 100 miles per hour east. And so you're changing the magnitude but not the direction when you scale by a positive number. So for instance, here's a picture of a vector v, and then notice 2v is in the exact same direction, but I've doubled the magnitude of the vector. And so basically we're just stretching or shrinking the vector if we're multiplying by a positive number. On the other hand, we can also scale by negative numbers. So if you have a negative sign, it changes the direction of the vector into the opposite direction. So here we see the vector v, and so negative v is just going in the exact opposite direction of v. We can also add two vectors together. So imagine we have a displacement vector v and another displacement vector w. So maybe I walk east for 1 mile and then I walk north for 1 mile. Well, you could either walk, if you wanted to figure out the displacement, you could either walk completely east and then completely north, or you could just connect those vectors and walk in the diagonal to get to the same spot. So if we look at a picture of these, suppose here's v and here's w. Now, what I could do is I can put the W at the end of V. So first I walk V, so that gives me how far I walk in the direction. And then when I get to the tip of V, I'm going to walk W. So I'm going to start with the tip of W and walk towards the other tip. So think of like this. So I walk here, my V, and then I get to the tip here, and then I walk here W, and I'm going to end up over here. There's another way to do this would just be to connect the beginning of this vector and the end of this vector and just go right across there the diagonal. And so that's how we define the addition. So rather than going each vector separately, we just add them together and go from the beginning of one to the end of the other. And that's how we add vectors. Notice if we started here and we went W and then V, we'd get in the exact same spot as well. So maybe draw yourself a picture to convince yourself that it doesn't matter whether we go v plus w or w plus v. And finally, we can also subtract vectors. So we can view a subtraction of vectors either as v minus w or as v plus negative w, because we know negative w is just w in the opposite direction. So if we want to, one way to subtract vectors is we can put v and w at the same starting spot. And then if I want v minus w, I'm going to connect the end of w to the end of v, like this. And how do we know these are the same, this is the correct thing? Well, think if I go this way, I have w. And then remember, when we place a vector at the end of the other, we add these two. So if I take w plus this vector, which is v minus w, those w should cancel out and I should get v, which is exactly what I get here. So if I wanted to do w minus v, I would do the opposite thing. So in this case, v minus w, you go from the tip of w to v. I would go from tip of v to the tip of w. So notice it's just the opposite direction of this. And the other way we could view this, of course, is we said we could also view it as v plus negative w. So I could go to v and then put negative w at the tip of that and add those two together, and that gives me v minus w as well. So notice v minus w is going kind of to the left of the page here, and think back of what it just looked like on the other one. Same thing, going to the left of the page, it's just shifted, and remember, where a vector is doesn't matter, so those are the same vectors. So that's two ways to get the subtraction of two vectors. So that gives us a quick introduction to vectors. Obviously, we're going to spend a lot more time on these, but make sure you're familiar with how to add and scale and subtract vectors, and we'll keep working further with these.